In this video, we are going to show that E1, E2 up to En in Rn are linearly independent vectors. First, let us recall that E sub I, it has all zeros except in the ith row. Oops, it doesn't have an I, but it has a 1. And the rest are all 0. Okay, the rest are all 0. So suppose otherwise. Suppose it's linearly dependent. Suppose there exists C1, C2, up to Cn such that C1 E1 plus C2 E2 all the way up to Cn En is equal to 0. Well, remember, this is just C1, the rest are zeros, plus C2 E2 is 0 followed by C2, and then the rest are 0, all the way down to Cn En. It's all zeros except the last entry is Cn, and this equals to C1, C2 up to Cn, because C1 plus 0 plus many more zeros is in fact C1, and 0 plus C2 is C2 plus a lot of zeros is C2, and 0 plus a lot more zeros is 0 plus Cn is Cn. And if this is equal to the 0 vector, that would imply that C1 equals 0, C2 equals 0, they all equal 0. C1 equals C2 equals Cn equals 0. That implies. So let's be clear what's going on. I wrote down a linear combination that gives me zeros, that equals 0. And it turned out that all the coefficients must be 0. All the coefficients equal 0. That implies E1 all the way down to En, E1, E2, all the way down to En is a linearly independent set. That completes this video, or this theorem. If you need theorems like this or proofs like this to help you out in your classwork, or if you're just interested in learning how to write proofs, or you want to see an individual proof, subscribe to my channel. In a short while, I will have them all. It's the only place where you can find all these proofs. And even if you can't find a proof, let me know, and very quickly I will write up the proof. So go ahead, subscribe to my channel. I'll see you guys in the next video. Watch and learn.